To obtain the solution of rational inequalities, that is, to obtain the solution of inequalities such as P of x divided by Q of x greater than 0, or P of x divided by Q of x less than 0, or P of x divided by Q of x greater or equals to 0, or P of x divided by Q of x less than or equals to 0, where P of x and Q of x are polynomials of degree n, where n is an element or member of the set of natural numbers, I have itemized 4 key steps that will guide you in order to obtain solutions of rational inequalities that take this form. First of all, you have to make all the terms to be on one side and then simplify the given inequality to assume any of these forms. And if you do that, you then obtain the root or the critical values of the given inequality. And how you do this is by setting both the numerator and denominator to 0 and then solve for the value of the unknown. And then when you must have obtained the root or the critical values, you then plot the root on a number line. If you plot the root on a number line, the root will partition the number line into intervals. You then test and choose the correct interval, and the correct interval will then be the solution of the given inequality. Now let's make use of this problem to see how we can solve given rational inequalities. So I have that n squared plus n divided by n squared minus 4 is greater than 0. Well, to obtain the values of x that will satisfy these inequality. So first of all, we have that x squared plus x divided by x squared minus 4 is greater than 0. Already, this equation or this problem have assumed this form. So there will be no need for us to simplify the given equation in order to assume this form. It is already in this format. So the next thing we do now is to simplify this further. I can say that x squared plus x divided by x squared minus 4 is the same thing as x squared plus x divided by x squared minus 2 squared. The reason why I do this is because I want to apply difference of two squares at the denominator level. I can then go further to say that this is the same thing as I can also factor one of the x's at the numerator level out, and if I factor one of the x's out here, I'll have one x here and then 1 here. And then if I then apply difference of 2 squared here, I'll then have x minus 2, x plus 2. Remember, the inequality states that this expression is greater than 0. So at this junction now, I would then set both the numerator and denominator to 0 in order to obtain its critical value or its root. So if I now set the numerator n of x to 0, that is, if I then have x into x plus 1 to be 0, this will imply that x is equals to 0 as well as minus 1. And then if I should then set the denominator to 0, that is, if I should set x minus 2 divided by x plus 2 to 0, this will imply that my x is equals to 2 and then minus 2. So we have obtained 4 critical values of 4 roots, and if you should then plot this root in a number line, remember, this is our number line. Here is positive infinity, and here is negative infinity. And so if we then plot this root, I'll have, accordingly, here will be minus 2, here will be minus 1, here will be 0, and here will be 2. So these roots, 1, 2, 3, 4, have partitioned this number line into 5 intervals. 1, 2, 3, 4, 5 intervals. So the next thing for us to do is to test each of these intervals to see if they satisfy the given inequality. So we are going to start from this interval that ranges from negative infinity to negative 2. Say, let's pick minus 3 from here or any other value of your choice. But if you should pick minus 3 here and substitute here, we're going to have minus 3 squared, which is 9, then minus 3 now, which is 6. Then we're going to have at the denominator minus 3 squared, which is also 9, then minus 4, which will give us 5. So 6 divided by 5 will give us something positive. So you see that this interval satisfies this given inequality. Now let's consider this interval. The interval that ranges between -2 and 1. Say we pick -1.5. And if we pick -1.5 or any other value in this interval, you will discover that on substituting it here, if you make this whole expression negative or less than 0. So that means that this interval fails to satisfy the given inequality. Now let's consider this third interval, the interval that ranges from -1 to 0. And if we should pick any value of s here, say -0.5, we will realize that any interval we pick from any value of s we pick from this interval, we make this whole expression positive. And so this interval satisfies the given inequality. Now let's consider the fourth interval, the interval between 0 to 2. If you pick any value here, say 1, you will also discover that this interval will be negative. And so this interval fails to satisfy the given inequality. Lastly, we then consider the interval that ranges between 2 to infinity, say 3, or any other value from here. You will also discover that this whole expression will be positive. So this interval satisfies the given inequality. So what this means is that among the 5 intervals, only 3 intervals satisfy the given inequality. So the union of these intervals becomes the solution of this given inequality. So we have that the values of x that will satisfy this inequality, or the solution of this inequality, will become this s that is on this set, minus infinity to -2, union, the s is here, -1 to 0, and then finally, the s is in this interval, 2 to infinity. So this is the solution of this given inequality. Keep practicing and see you in my next lesson.